Hello, welcome back to the TCO19 finals. This was not on the schedule, but we do have a hackathon presentation round that's happening. It's called the Shell Game Changer Hackathon. We're going to have about 9 to 10 presenters, and we're going to bring that to you live here in just a few minutes. They're getting ready behind us, and it seems to be pretty exciting. There's a lot of chatter going on.
Yeah, hopefully you guys can hear us amongst all the chatter. We have an audience starting to assemble. So little bonus live broadcast for everyone who was smart enough to click that follow button.
No, hopefully it should be exciting. We should see some interesting submissions here for this hackathon. There was something about it on the website. So if you go, you can probably check out what they're going to be trying to solve here.
Well, we're going to get a full introduction, Nick.
We will.
So don't worry, we won't be the one talking you
That's
through
not
that.
going to be us. We're going to head to the stage in just a few minutes once they get started. The interesting thing is that some. Check.
Excuse us one moment, technical difficulties.
All right. Yeah, I heard a little loop. Heard a little loop on the the arena audio. So I've run into that one too many times. I feel like here already.
I think it's too many times.
That's true.
All eyes on production.
But here's the thing. We do have some of our members that are competing in it, but we also
they're all our members competing in it.
No, there's some top coder members that live in this area because
Top coder members.
Right.
Okay.
Because they have to physically be here and to present, or at least have a team member to present at this event.
So interesting side story that's part of this competition right now is that a number of the presenters are part of the development finals, which are currently still ongoing. The dev finals were extended by an hour, so they had additional time to submit, but now some of these folks are going to go straight from submitting their development finals directly into hackathon presentations.
So it might be a little jarring for them, but luckily that they were they're set to present a little later, so they're kind of like at the bottom of the list of presentations that are happening.
Yeah, so we at least tried to accommodate them. It's a tough schedule. TCO is grueling. It's competition, so you got to be able to fight through that adversity. So hopefully after 4 hours of development, they're able to go stand on the stage in front of everybody and talk about a completely different code set.
Yeah.
We won't tell you who it is, and we'll see if you guys can figure it out.
Hey, if you've been following along, you should be able to point out the ones that have been competing already.
That's very true, Nick.
So you just, grab your popcorn. It's how you do it in the biz, You don't really eat the food, but, this time I did.
Yeah,
Would you like some popcorn? It's going to be a good show.
I'm not going to eat popcorn into the mic. But
all right, that's fine. How's the TCO been going for you?
It's been a whirlwind of activity, Nick. I know I've been on less than I have in the past. We've had more members. We've heard a lot of feedback that we want more subject matter experts coming on to talk about in-depth problems and strategies. So that's something we've really been working on. Doesn't change all the stuff that happens behind the scenes. So when Nick and I aren't on, we're running around like chickens with our heads cut off, making sure that this production is going on well. We have an awesome team behind us, getting all of our AV going, doing all of our transitions, our graphics. It's every year like a bigger and bigger production, and a lot of work, but a lot of fun too.
Absolutely. A lot of new competitions, a lot of new formats of these competitions we've been able to experience this year, so that's been exciting as well. Adding new tracks such as QA.
QA, I was really impressed by the structure of.
It was really cool.
This isn't a dig against QA people, but it's hard to make testing exciting. It's a challenge. I feel like they found a way to do it with that challenge phase, having the ability to affect your competitors' scores and flip the scoreboard. It's a lot more interesting than just a count of bugs that you found. So, really great work from that team.
Thank you to our sponsors as well for sponsoring this event. A lot of this is all due in part to you all as well. We work with a lot of these companies too on projects.
Oh yeah, we have a number of our customers sponsor the event, and a number of other companies local to the area sponsor the event, such as Shell with the Game Changer Hackathon. coming up in just a moment, I hope.
Right.
They're just getting everyone mic'd up and ready to go. So we're expecting that to start any moment now, and it should really be interesting. It'll begin with some of the folks from the show coming on stage and explaining what the challenge and the problem. There should be a pretty cool welcome video going on, kind of outlining what's going on, what Game Changer is about. So that's why we're sparing you that now, giving you the opportunity to hear that directly from the source in a couple minutes. And then it goes right into the presentations. And some of them are teams, some of them are individuals. All of them should be pretty good.
No, I'm looking forward to it. And what do you think, what should they be expecting for tomorrow? Tomorrow's a big day. It's our final day.
Yeah, tomorrow, final day of the broadcast, so you can expect me to be partying when it's all said and done. But really, the story of the day tomorrow is going to be the algorithm finals.
Algorithm finals, but we also have the design finals as well.
Yes.
We're going to find out who the last 4 designers standing are, and who will walk away with the trophy.
Yeah, I mean, this is a new format for the design finals this year, doing the bracketed head-to-head matchups, double elimination, up to a point, then single elimination once you made the first kind of cut, I guess you can call it. So 4 members go into the UI design finals tomorrow. It's going to be an exciting thing, and we don't even know.
Yeah,
No
idea.
We have no clue who's going to make it out of the 8 who competed today. Or sorry, 9 who competed today.
9 competed. Yes, it was an odd number.
Yeah, so five competitors. We'll find out tomorrow morning that their TCO journey is over for this year.
Right.
And then we'll just have a really exciting final between the remaining. And then the algorithm finals is always the marquee event of TCO every year.
Exactly. So if you are interested in seeing any of your favorite members, you may want to chat to us live, and we'll do our best to either get them on here, or if they're competing, we'll show their screens to you so that you know what is going on with them during the competition. But this is always an open forum, guys. Chat us away. We'll be happy to read, respond.
Yeah, this is your chance right now, because we have we're eating up airtime until this thing starts. So please send any comments or questions our way. Anything about TCO. But Nick, what did you think of the algorithm show earlier?
That was exciting.
We got to be spectators this year.
Yeah, no, thank you to Scott Wu, who took over hosting duties. He did such a great job. So many great comments about Scott Wu.
He's
the
awesome.
host. You know what they really liked? They liked him trying to work through the problems live.
I know. I actually was sitting in front of the stage watching the scoreboard, but I had my laptop open and my earbuds in. And I was listening to the broadcast while I was walking around, checking out screens and getting the analysis. I especially love the way that they kind of start drawing out solutions to the problems and sharing that, because it helped me understand it a little bit better. I'm not going to pretend I understood it, but I understood it a little bit better. And like every year I got a little bit closer to understanding what these competitors are able to do. I mean, it's super impressive.
I mean, I think this is one of the first times that I've seen, is it four members got all 3 problems correct?
Yeah, and it was nice that we had the problem writers on the broadcast as well, because I noticed that they were kind of taking some jabs at themselves, like, oh, did we make these too easy?
Yeah, right. No, you know what? I want to backtrack.
Good?
I think it was 5. 5 got all 3 right, because we had Eknerwall, who got burned on that in the challenge round.
Yes, his 500-point question got challenged by. I would know it if I remembered, but I don't.
I would have had it here, but that's okay. It sounds like we have things happening on the stage right now, so let's go over and see what's going on.
I don't hear. Thanks.
So I'll speak first.
Yeah.
So good evening, everybody. I'm Haibin Xu. I'm very happy to be here. I'm the manager for Shell Game Changer here in North America. I have to confess, I have a bias towards top coder, because my girlfriend, who is here in the audience, she competed in top coder when she was an undergrad in China. So congratulations to all the coders who are the finalists today, coming into the Shell Game Changer Hackathon. And we'll look for a really exciting pitch from now. But before that, I'd like to also recognize Carolina Real. Wave, please. She has done a really terrific job pulling this together over quite a few months. And we're very, very excited because this challenge we put forward is one that we care deeply about inside Shell, and we really look forward to some excellent ideas and solutions from the pitch. Thank you.
Thanks, Ibin. Hello, everyone. I'm Deval Pandya. I'm a data scientist in our data science COE. And as we know, energy industry is rapidly changing, and AI has a big role to play in it. So we are looking forward to collaborating with everyone on how we can solve the biggest problem of our generation, which is providing more and cleaner energy for everyone. Thank you. So, hello everyone, it's me again. Before we start the pitches, I just wanted to briefly tell you a bit more about what was the challenge which was presented to our contestants here. They were presented with several months of sensor data which we have been collecting at one of our platforms for a very specific instruments. They don't know what this data is, so whether, say, it's pressure or temperature, they don't know any of that. They also don't know what kind of instrument it is. So what the challenge is, can we use data-driven approaches, purely data-driven approaches, to predict when an instrument is operating in abnormal regimes or when it's going to fail before it actually reaches that state? And yeah, here you go.
Hi, everyone. Still waiting for the screen to come up. And I can see some of the glimpse. And at this point of time, I am also present in that cubicle because my development finally is also running. But I'm utilizing a bit of time because there are some issues with the platform. So an abstract of this, till the time this would come at the screen, I would utilize my 5 minutes, I guess, would be, again, added with another couple of minutes, right? So I would utilize that one to my profit, I guess. Okay, so as an abstract, as he kindly mentioned, that for the Shell Game Changer 1, and the solvers were asked to understand the anomalous event, so the events which are actually anomaly, not an actual event. And to do that, what my proposal was to have a training-less kind of algorithm. And I would explain in a bit what do I mean by the training-less. So this term sounds very catchy, but I would explain it technically. So as you can see my screen, and this is also part of my submission, that this PDF as a report. So the first section is the abstract, and as you can see, so this is the whole lot of data which the solvers had received. Hi.
Can you just state the name of your team?
Oh, my team name is Pupa AI. And do you wonder why I put that team name? Okay. Because the pupa becomes butterfly, and that becomes beautiful. So I want to start a startup which would make the world beautiful. That's what. Okay, so now come back to the point of this Shell Game Changer. And this is a whole lot of training data which we, the solvers, have received as part of the training process. And I had this marked with the black lines that which are the anomalous events. So the approach we have taken to understand these anomalous events will be discussed later. But first we need to understand, did I really crack it? I mean, did I really understood what are those anomalous events? I strongly believe yes, because as you can see, these orange color line, which is the answer of my algorithm, and it is created by my algorithm, which is a training-less algorithm. And we are really be able to understand with these peaks that these are the anomalous event. I would do a more technical briefing on that. And the upper portion is the training data, where we can see the anomaly, and the lower portion is the validation data. One thing we need to understand that all of this training and validation data, when we solvers had received that, we had the target value. So I appreciate that in a real world, the target value will not be there because we need to predict it from, say, for example, 2 days ago or 3 days ago, and how future we can do that, that is one of the evaluation criteria as well. But I will go into that part. But the main novelty of this proposal, which I believe, is this training-lessness. So I had used a recent technique called matrix profile. And using that technique, all those references has been mentioned in the report. So the overall algorithm and the framework is divided into 3 parts. First, obviously, we need to do an ingestion of the data. So the ingestion part is going with the rolling time window and the overlap of 10 to 15 days. because we need to do the overlapping because to understand the boundary conditions. Because say for example, if an anomalous event is probably on the 59th day, so I won't be able to understand that where that anomaly is because with 1 day of data. So that's why these 10 days and the 16 days had been, I got to know these 16 days after doing some exploratory data analysis. So that's why the 60-day and 10 days combination of the data ingestion. Then the next part is the data processing part, which is the most interesting part, and I believe I had enjoyed a lot while doing this data processing. As I told you earlier that I had used the matrix profile and using the Python library, so all those libraries are available as an open source. So using that matrix profile and the traininglessness of this algorithm, as you can see, this is the algorithm in a nutshell. So we first break the data into several chunks and then process that chunk. We can also have the overall data of 3 months or 6 months as a whole to process the matrix profile, but that would take some more time. So to have it in a real time, so my future goal is to have this solution as a real time. So this is the first step, I believe, to do that. So I had break the data into different chunks, and after doing that, with the matrix profile, what matrix profile does is actually getting these anomalies or the discords or the motifs or the pattern, these kind of things, with their localized parameters, like within the 2 days, has there been any pattern? Within the 4 days, has there been any pattern? So instead of looking into the whole 60 days, it is looking into a 4 days chunk within those 60 days, that is there any pattern repeating in every 2 days or every 4 days? Is there anything else? So that's why I had created 3 trial parameters with the 2 days, 4 days, and 8 days. And after doing that, with the exploratory data analysis, I came to know that there is a threshold of between 0.25 to 0.5 within the target value range, which can actually give us whether that event is an anomaly. And the width of those anomalous data is around, so in the training data it was around 2 days, in validation data it was around 4 days, and in training data in the 2017 part, there were 2 anomalies which had around 8 or 10 days. So those were the reason behind these 2, 4, and 8 days parameters. Now, okay. And now as you can see, this is the validation part where we were able to do the weightage and get to know which section is the anomaly. And as you can see, in this section, in 1, there is no anomaly, but from 2 and onwards, there are the anomalies, and these are the weightage, and we have the confidence that there will be an anomaly. So this proves that we can actually understand from past, I mean, we can understand the future whether there would be any anomaly or not. Then the inference part is easier, that we can do the prediction of the target. And the most interesting thing, this is a decoupled architecture of the AI, because you can do any sort of prediction. You can use LSTM, deep learning, AI, reinforcement learning, anything, but you still can use the traininglessness of these algorithms to couple with this prediction target. So in future, in the next phases, if I may do this one, then the prediction would be more sufficient. But right now, this is the 0.015 RMSE score with the prediction. And then the predicting event onset, as you can see, these are the event onset, which I have predicted. So in the overall thing, the answer is there are 3 events, which I believe, event 1, 2, and 3. And at the point of submission, I didn't have those dates. So that's why I used the index position. That 5918, 7592, and 25351, these are the index. And the 80% data variability can be explained with whatever the algorithm I have used. So if there is any question, I would be happy to answer. Thank you. For the future events, the generalization, do you mean by, I mean, the data or from the algorithm perspective, how the algorithm could generalize the overall prediction? Okay, so the real interesting thing in this algorithm is the generalization is the heart of this algorithm because it doesn't require any sort of training, and that means we do not have any assumptions, and as we do not have any assumption, that means we do not have any wrong assumptions. So like, as you know, in deep learning and in any other machine learning algorithms, we have some distribution assumption that it should be a normal curve or anything. So it is pretty robust, and the main thing is the traininglessness of this, because you don't need any sort of data to do the training. You just need your business knowledge, like those parameters, how the threshold value would be, because I believe the Shell guys would actually know what those values would be, and with the EDA I could get the values probably 0.25 to 0.5, and you just put those values and you do not need anything. So you can use my algorithm for any unseen data any day, but you don't need any training, so that means it's pretty generalized.
If this is not based on any assumptions like usual models, you are purely based on what the pattern is changing in historical data. Is that correct?
Yes. So a part of this is the traininglessness, where it is not based off any assumption, not based off any training. But from future perspective, as I appreciate that, say for example now, today, you want to understand within 7 days whether there will be any anomaly or not. So that looking forward kind of predictions, obvious. So that's why I was mentioning that these architecture is completely decoupled architecture. So you can use the traininglessness to understand the anomaly, but using your in-house algorithm or any other algorithm, you can do the prediction. So say for example, at today's day, you can predict 1 month from anywhere, and you can use this algorithm on top of that prediction to understand in next 1 month whether there would be any anomaly or not. So that's how the algorithm will work.
All right. So if there is some pattern that hasn't ever been seen in the training set, do you think that can still be captured in the future?
If there is any, okay, so that's why those patterns, so if the nature of the pattern is completely different, so say for example, after doing my exploratory data analysis, I saw the pattern is like a spike, then that spike stays there for some day. It might be 2 days, 4 days, 8 days, depending on the data. So the training and the validation data, there were 2, 4, and 8 kind of things. But say for example, now you had a kind of spike which is not those staying pattern. So instead of 2 days, the spike is for 1 minute, and you still call it as an anomalous event. But you still can actually put that as an argument that, okay, I do need to understand this an anomalous event. It is not just a random event. So it's completely with the business knowledge. You put your business knowledge onto the algorithm, and the algorithm will look back for the patterns, the localized pattern moreover, and it doesn't need any kind of training, and it would give you the output with your prediction data.
Okay.
Thank you. Is there anyone else with any question I can help you with? Okay, thanks.
All right. Team Pupa AI, and I wanted to welcome Team KDI to the stage.
Before my computer. Sorry for waiting. are three parts of my speech. First, we need to predict target on test input date. And well, this is the easiest part because we already have very mature methods. We usually always use random forest-like algorithm. Let's group to solve this kind of problems. These are three most common labs. And these three labs won't make too much difference except for fine-tuning the model. So you just choose anything. And it also gives you features importance for each columns. And it trains on training field, evaluate on validation field. And you can see that the error is really small. And you can see that the predict target and the real target are almost the same. And this is a picture predict on test input date. You can see that this is a test data set. This part and this part is supposed to be the abnormal date. I use pure mathematics to calculate the abnormal period. First, I split the dataset into two parts, abnormal part and the normal part. Second, calculate the abnormal and normal distribution. Then, given a target number x, calculate the possibility x appears, which is x, the possibility of x appears in the abnormal part is P1, and P2 is that number appears in the normal part. And I use the following function to calculate the possibility of x belong to the abnormal part. These are just pure math. And third, I use the possibility for each data point, whether they belong to the abnormal part. I use it for 1 day moving average to calculate it, because the minimum, all abnormal parts are longer than 2 days. So I just use 1 day. And for event, the result is really good. And it's even better on the predict target we created in the first part, which use XGBoost. For the evaluation part have 2 events. You can get the exactly same start time, but it detects 3 abnormal parts in the validation set. You can see why, because there are 3 peaks. And we use it to predict on the test input date. It predicts 2 abnormal periods in test input. And I'm sure it will be good. And this is the start time and end time of that predict event. Third, this is not required, but these are unrelated features to the abnormal time period. You can find it in the third part of my Python notebook. The concept is very simple. For example, if you see this is a column where 38. It has only one date value, which is 1. Others are all 0, and that date is not in the abnormal period. Then you can just remove the whole column because the coordinate only have one information, which is unrelated to the abnormal period. In other words, the column contains something abnormal, but it's not the date what we want. Maybe, okay, maybe just a dog predict it's nothing. And if a column has concentrating distribution date, for example, like this, over 95% of dates are 0, and 5% non-zero points are not in the, and all these non-zero points are not in the abnormal period, then this column is unrelated. You can safely remove it. Because the data is imbalanced. So even you add another coordinate to it, for example, use 2 columns, 3 columns, it will still lead you to these unrelated peak findings. These columns just, you don't need it. And there are 53 columns can be safely removed. And any questions?
So have you tried to test results on without removing the tags? Then you just said it's unrelated, and with removing those features, then unrelated.
In fact, we just got it yesterday, and we have a whole day's competition, and running that cost a lot of hours. Yeah.
All right, thank you.
But I think that these features are unrelated to the abnormal period, but it's related to the target maybe. Yeah.
Any other questions? Okay. Another round of applause, please. Great job. Thank you.
ADA, and I'd like to welcome Team QWERTY to the stage.
Hello, can you hear me? Yeah, perfect. Good? Awesome. Hey everybody, I'm Vinod Rodriguez and I'm from Toronto, Canada, and I'm here representing QWERTY KI. And what we are is a small startup coming up that we're focusing on building ML applications and AI applications with a very specific focus on manufacturing and the manufacturing industry. And what I'm hoping to do today in the next few minutes is actually go through the way we solve this problem, the way we tried to solve this problem. And I'd like to do it, instead of going through a deck, is to actually go through the platform that we're building and show you how we solved it with the platform. All right? Awesome. So everything's web-based, and what I've done is basically I've uploaded the 3 data files that we were given, so that training set, the validation set, and that final data set. And we just concatenated them all together, no changes, and uploaded that CSV up to this program. And the goal, as everybody has mentioned, is to be able to predict that target variable, right? We need to be able to understand how this target variable reacts, what the features are that influence it, and ideally predict that sometime in the future. So what I'm going to do is just choose my target as my target column here, and ask the system to basically go through and get this data set ready for data analysis. And what it does is basically parse the data, look for all those missing values, cleans it up, nulls, corruptions, anything that you'd be spending time in data processing. Let it take care of it for you automatically. And what it's going to come out to me and give me basically is a clean data set, and it's asking me what I want to do. Now, the way we've designed this platform, the way we try to build this platform, again, was a focus on manufacturing. But not just that, we want to really focus on the SME, the subject matter expert and the process engineer. We built this machine learning and AI capability for them to use. We want the SME, not the data scientist who can code all this, spend all their time data processing, the engineer to use this. So we've built it down into 3 major workflows. This workflow, we want to do a prediction on this target, right? So I'm going to choose the prediction workflow here. And I'm going to be shown my target variable right now. So my target variable looks something like this, which is, again, what everybody's seen. And this is that test data set. We've just padded it with zeros because it was empty, basically. So the way we approached this problem for the actual submission was we were very meticulous in choosing that training and testing range. We wanted to choose training and testing ranges that were indicative of the baseline operation of this asset. And ideally, that's what you do in a manufacturing environment. But for now, I'm going to be very naive and very quick and just say train on that. All right? So I'm going to choose that entire whatever 2 years worth of data to train on. And obviously, we want to predict on this. I'm going to say test on that range. Right? It's very naive. I understand we wouldn't do this in a manufacturing and production environment, but for speed purposes, I'm not going to select the individual things. I'll say, let's save and continue. So what we're doing at this point is we're going to go through all the features in our data set, and we're going to start pulling out the features that are important to us. And we're going to look at it in multiple different ways. We're going to look at it as what features can most accurately predict that target, right? But as well, what features are dependent to that feature? Or rather, the relationships, the nonlinear relationships, all those things, we want to extract that information out. And what we're doing right here is basically ranking all those features for you. So you can see here basically which features are most important in terms of predicting that target variable that we chose. Now, this is where we want that SME input in. This is where you come in and say, as an engineer, this feature makes sense, pressure, temperature, makes sense, differentials. I don't know. I'm going to do this as naively as possible and say, just choose my top 5 features. All right? So I'm going to choose my top 5 features, and just for the heck of it, I'm going to choose one, build another model, but basically the top 2 features, and see what we get. So I'll train and validate this model, and basically it's wrapping this model up, getting it ready for all the predictions, and it's going to show me what the prediction is on that test data set, that test range I chose. So this test range is basically our final data set that was given to us, and if we look at that, well, it looks like 2 very abnormal events to me. So this is what, so far, we've predicted in that final test range, building the model as naively as we did on that training and validation data set we've given. But this isn't the end of it, right? We want to be able to see which features actually influence this. We have a list of those features that I, again, really quickly chose, variable 21, 168, whatever, to be able to predict this, but we want to see what influences this. How can we accurately predict this ahead of time, correct? So the way we approached this next part was saying, well, let's look at this time in here. So if I was to zoom into this time before this abnormal event is key, right? That's the crucial time where we can pinpoint and say, okay, this feature is acting up, this is going to predict that. So what we did was build classification algorithms following this exact same workflow, going through the exact same process, and say, what series of data, what range of data basically makes it distinct enough that I can say, this is different than the rest, and this is indicative of a failure, all right? And we came up to about a range about 6 to 7 days. And what we did was say, well, let's look at that range and see which features in those range are actually different than the rest. And we have a list of features that are in the submission and all that such. What's our next step? Well, what we do is build anomaly detection models on those features. And I'm not going to go through the building of that process because I'm just getting 2 minutes here. But I'll show you what that model looks like. So I just built one really quickly, about an hour ago or so. And it looks like something like this, where I built an anomaly detection model here on variable 0. And you see variable 0 acting fairly periodical. And at this point here, we see the actual abnormal event happening. And before that, we see impulses in anomaly score. So the anomaly model output is actually a score from 0 to 100. And we've normalized it to say basically 0 is normal. It looks like your training range. It looks like your baseline operation. 100, I've never seen this before. This is different. Not bad, just different, right? And this is where, again, the SME input comes in and says, what can I do about this? Can I go to my features and see what is different about this? Why is it different? This is where that context is really made in AI. So in this case, it looks like up to, I'd say about 7-ish days. I'm getting impulses in this variable that's saying it's different. And ideally, that's where we start investigating it. So at this point, I'm actually a few clicks away from being able to say, wrap this model up and deploy it. If you got data sources like, I don't know, DCS systems, data historians, PLCs, it's a few clicks away from connecting it and then deploying it. That's our presentation from QWERTY KI. I'm getting the signal I got to wrap up. So if you have any questions, I'd be happy to answer them.
Round of applause, QWERTY AI. Nicely done. I got a feeling there might be a question or two from this curious audience. Any takers?
No.
Yep, all right, here we are. Thank you.
Thanks for the presentation. Just kind of curious about, can you shed some light about the algorithms behind the scene for the anomaly detection, as well as some of your approach that, is it an ensemble-based methods? Or?
So it's, we are using the usual algorithms, XGBoost, LightGBM, all that kind of stuff, and there's a little bit of IP in there as well. And much of it is a heuristic search in the background. So we are going through multiple different models to find the best search for the best workflow, given the data set. And it's all done through a training test split cross-validation as well. So there's a lot of work in the background that's happening. And I'd be happy to have that discussion, answer that question offline when I'm not being recorded. But that's about it, yeah.
Any other questions? QWERTY AI? Once, twice. Big round of applause. Thank you very much. Great job. Nicely done.
Thank you again, QWERTY AI, and I'd like to welcome Team Dr. Rice to the stage.
Hi, everyone. Thank you for being here. So we are Team Dr. Rice. Today, our group will present how we can use the gradient boosting tree models and long short-term memory models to forecast the abnormal events during the deep water drilling process. So the question is, how can we forecast these abnormal events in advance, as shown in the upper figure? And the bottom figure shows the data we have. The black line shows how the target signal changes along the time, and the red boxes has marked out all the abnormal events. So to solve these problems, we developed two approaches. One is offline prediction, the other is online prediction. So for the offline predictions, we have first, with all the data set we have removed some variables which are not very informative, and then for each of the variables, we use the Hamburg filter to remove the noise. So with all those variables available right now, in order to predict the abnormal events in advance, we have shifted our input information 12 hours ahead. And we created some new variables by summarizing the information using different time window length, including like short-term, long-term, and mid-term. With those informations and variables, we have built our models. So that's not enough. We try to predict it in advance. So that's what we do for our online prediction approach. So in this approach, we have used the LightGBM and long short-term memory models as our model architectures. So for these two models, we have our data flow in, and we generate the features and the input, and made our final predictions every 5 minutes. So this is how the models looks like. With our on-scene test data, in the top figures we hear, this is the target signals we predicted. And the red and this blue lines indicates the start point we have captured. So the bottom table shows the details about the prediction. Using our offline prediction models, we have captured the starting points of the abnormal events at 5780 and 25220. And our online prediction model captured the events for 5880 and 25280. So it's worth to know that because our online model is predicting 12 hours ahead. So if we use the offline model as our reference, we can predict the first abnormal events about 10 hours ahead, and the second abnormal events about 11 hours ahead. So right now we see, okay, our model performance looks good. So what are the variables which are associated with our models? So as I mentioned, we have created some new variables during our model building process. So we have the left figures show the variables which are showing the most importance in terms of variable. We have the top 5 most important variables, including variable 0, 182, 6, 183, and 7. And in terms of time windows, we have found that the using the 5 hours, 1 hour, 2 days, 7 days, and 9 hours show the most important. And for those time windows, we already shifted 12 hours ahead. We also tried the long short-term memory models to do the prediction, and here is what we predicted in our validation data set. The blue lines is the true target signal, and the yellow line shows the predicted signals. However, like during the time issue, we don't have enough time to build a final model which will capture the starting point. So that's what we have here, and we are willing to take any questions.
All right, any questions from the Shell team or others? Questions? Yeah. Oh, there we go.
Thanks for the presentation. I have a question on the last slide. So when you say you are using prediction versus actual, are the predictions being made at the same timestamp, or they are being made earlier in time dimension?
So what we show here is the timeline, but the data, the input information is like shifted ahead. Yes.
And how ahead is it shifted?
So if you can see the figure on the right-hand side, right? We have a time gap between the feature we are used for the model and the corresponding events, right? So basically we have, suppose that in order to predict the time at time t, we actually use the feature with the information that t minus tau. Tau is the time gap we consider, yeah.
Yeah. So in that last graph, what is that delta or tau? How far out are you when you are predicting it?
For this long short-term memory model, we use 30 minutes ahead.
All right.
Yeah.
Thank you.
But for the left model, we use 12. That's why we can achieve about 10 to 11 hours prediction ahead.
Got it. Got it. Thank you.
Sure.
Any other questions? All right, big round of applause. Thank you very much. Good.
Team, thank you, Team Dr. Rice, and welcome to the stage, Matrix Design.
Yeah, am I live? Yeah. So hi, I'm Ketan Singh, and I'm representing Matrix Design. So I'll just go through. So like this task is like pretty like tricky to define, because like it has elements of like anomaly detection, and one could also like pose it as a regression task or a classification task, and this like. And there are like many sub areas inside that. Like you could use normal anomaly detection methods or like new ones. But I'll just go through the things that I considered and what we finally decided to do. So the first one that we considered was like the Gaussian modeling of non-anomalous cases. Yeah, I mean the good cases basically. And like this was recommended by like Andrew Ng. So I think like many of us are familiar with him. So basically the point is that we actually like model the like the good data points, so that the points that are outside the Gaussian model, they'll show up as like anomalies, okay? So I actually tried doing that, but like as suggested by Dr. Ng, that one should actually like visualize it first. So we did this, and as you can see, like this is in 2D. Like the actual data is like in a lot of dimensions. But as we can see, there's a lot of overlap. Like the red one is the anomaly, and the blue one, those are the good cases. So there's not like a clear-cut way to like distinguish them. So I actually gave up on this. I mean, it could work, but like as you'll see, there are like better methods to do it. So yeah, and then there are like new ways of detecting anomaly. Like we have autoencoders, which actually like compresses the data and like creates data from scratch. So we could use that, but as you'll see, So I'll just come back on this. So, and the third one is like we could just model it as a time series. We could use it as, we could make use of LSTM or like any kind of RNN to like get a time series kind of a prediction. But as we'll see that there are some issues with that. So actually, I did try using LSTM with like 2, 3, or like 4, 5 parameter configurations. And as you can see, the orange one over there is the prediction, and the blue one is actually the target, which was available to us. But as you can see, it's almost the same. We don't get any onset prediction over there. Like it's almost exactly the same. So it's not like you could use it because it does the job for the rest of that problem, but not the onset. Like in fact, it's a bit late. As you can see over there, it's a bit late from the onset. So yeah, so we cannot use LSTM. Like this was the first thing that came into my mind, but like it didn't work. Yeah. So basically, what I've used is like simple classification. It should be like a regression, but I'm sorry. Like it's a basic deep learning based regression. So, but for that, what we have done is we've modeled because the information in the target column is not very informative. Okay. So, and the key task over here is, the key discovery over here is that a lot of information is available at the data point level. You don't need the time series information. Individual columns are enough to like inform you about the what's going to happen. Like this was a surprising thing because this like usually doesn't happen, but it did happen in this case. So what we did is, for labels, what we did is that we recorded the estimated time of arrival of the anomaly, and we used that as the regression label. Okay. So for example, if the if the anomaly happens right now, like this is time 0, and like every minute before that is like 1, 2, 3, 4, up to like 2880, like that is 2 days, like basically like So so that is how we modeled. That is how we set up the labels, and because it was clear from the outset that onset detection was the key for this task. And so like this is the what we used. Like basically the first one was like this is a very huge network because we had a lot of data. So we used a huge network. It has a lot of layers in it, and to make it generalize well, we used a lot of dropout layers, and we used ReLU in that. Like that was a big game changer because until we were not using that, the performance was not that good. But once we started doing it, the performance went, it improved a lot. And the batch size was like 5,000. And like I tried a lot of iterations, and we converge on this. Yeah, so this is the current state of the art, for me. As you can see, the orange one, it starts sharply rising before the actual event. And it's like roughly 200 minutes in advance. So that is like 3 hours. So we actually have, as far as I can see, my algorithm is, our algorithm is able to predict like 3 hours in advance. Yeah, at least in the validation set, for both the failure cases, we saw that. Like this is the second one, like in validation. As you can see here, it's a lot in advance. Yeah. Yeah, so there was another interesting thing that we noticed. Wait, I'll just, yeah. Just a minute. Yeah. So as you can see, like there are actually a lot of spikes over here. So someone actually asked in the forum, like, what are those spikes? Like those look like problems. So the response we got was like those could be like external origin issues. Okay, and like right now we are focusing on only issues that are of business interest. Okay, so what we found was there is actually no way to pinpoint what is of business interest or what is an external failure, but we can use heuristics for that. I'll discuss that ahead. So basically, like something interesting is happening if the value, whatever the value it predicts, is above 0.15, If it is like 0.2 or above, like something bad happened. And like we need to start worrying if it's like above 0.25. And if it's a spike, like I showed you the picture, if it's a spike, then it's most probably an external issue, and we shouldn't be too concerned. And if it continues to rise, that is a proper failure that we should be concerned. So yeah, and a quick oscillation is also like not a concern for us. So like this is a very crude heuristic that we can use. Yeah, the alternative is we could actually build a secondary model. We could build like a secondary model over this, and, which could do the prediction, which could use the like the output of the first one as the input and do the prediction. It could basically classify what is of business interest and what is not. And yeah, so we also have like causal inference. We can predict what are the important features and all. For that, we have used like feature importance. That is like a very simple thing. Like we have not used like deep learning for this. And future work, like we are planning to use, like we are planning to ensemble this with like other deep learning methods. Like if we have a lot of more data, we could actually try LSTM once again. And we could also like ensemble it with other ensembled methods like LightGBM, XGBoost, or CatBoost. Yeah, so yeah, thank you.
Good job, thank you. Thank you so much. Questions from the Shell team or others? Any questions? Yes, great. Thank you.
Did you ever count how many times your model prediction is saying there is going to be an event, a failure, or a spike, but there isn't actually one? So basically false alarms. Did you count?
There isn't?
No.
Like based on the heuristics I talked about, if one follows that, like if you only get worried if it crosses like 0.2, like there's nothing like that.
Okay.
Yeah, and that's like very easy to solve if you use a secondary, like a secondary classifier after that. Yeah.
Any other questions? Okay, big round of applause. Thank you very much.
Thank you, Team Matrix Design, and welcome to the stage, Team Bezier Brothers.
Oh, there we go.
Yep.
Hello, my name is Patrick Lee. My name is Edward Ewan, and we're on Team Bezier Brothers. So when we approached this anomaly detection problem, we kind of asked the question, what's the simplest way we can go about this problem? And we just went through, what about just a binary classification problem? Are we able to actually predict just normal and abnormal? So we went with that premise, and we're actually able to actually develop a dual system model. So the first model was actually our warning model. That'll be the actual anomaly predictor. It was trained to actually be sensitive to any onset of any abnormal activity. And then the second model is a critical model, and that was trained strictly on knowing when it was in the anomalous region. So in tandem, we hope that by having these two models that working together, we can have a better understanding operationally where we're at. So if we're in the warning, we can take lighter, moderate intervention and we're in the critical, we can actually take more severe measures. In creating the model itself, we went through a couple data processes. The first one, as you can see on the top corner, the data was pretty noisy, so we did a lot of pre-processing and removed the outliers. Next, again, good data, but there's a lot of variables that wasn't really pertinent to the model itself. So we went through, selected the features with some methods, feature importance, recursive feature elimination. And through this process, we actually settled upon an XGBoost model as our base model for the final model. Due to the fact that it's still a powerful algorithm, but at the same time, we're able to interpret their variables and their feature interactions out of it. So from our test result, you can see on the chart right there, blue is the actuals, and orange is our prediction. So it does a really good job of identifying the anomalous region with some false positives. I'll go back. You can go back real quick. Oh, yeah, and then with the warning model itself, we were able to predict 1 hour, 30 minutes ahead for event 7 on that validation data, and for event 8, it was actually 16 hours and 30 minutes. And running that same model, that was only just trained on the train data itself, we still were able to detect it on the release holdout set. And the warning time was 4 minutes and 10 minutes. I will hand over to Eddie.
All right, so we also spent some time thinking about how our model will interface with the users, so like your operators or the people in your control center. And we actually built a prototype. Is this too loud? Okay. So we built a prototype in Tableau to kind of illustrate what we were thinking about how the models will be used on site. So just a quick explanation here. On the top left corner, you see this big status sign, and it'll tell you if your system is in a normal operating parameters, a warning, or a critical. And then next to it, we have warning and critical indicators, which are fed directly from our model. So the percentage gives you the probability it's in that zone. And as the warning indicator probability goes up, it'll switch the status to warning, and same with critical. So this way, when you're an operator, you don't need to look at many numbers and different things. You can just see what state your system is in. Also, without much context, we put the top 10 features under this. So as an operator, you can see how the different features are fluctuating with time. And I'll do a quick demonstration, if I can find the mouse. Oh, there you go, of how it's going to work. No? Doesn't want to work? Oh, there we go. All right, so right now we're in the normal state. Is it moving? Okay, right now we're in the normal state. So everything looks like it's running smoothly. Then now we're in this warning state, and you can kind of see on this bottom right-hand corner, there was a deep drop in that feature. So as an operator, I'll be like, oh, what's going on there? Maybe investigate. And as we keep playing it, and this is event 7, by the way, we hit the critical state. But as an operator, I don't know what's really going on right now, but I know something's going to come up. So if we keep playing this, you can kind of see all the different features continue to run. And then now you start seeing a few features changing or trending in an anomalous way. So you can see like this one, and this one all had a spike. So then I would go investigate to what's going on in these features. All right. So in summary, we believe our model does accurate predictions, right? It predicted the start times of all the abnormal events. Our solution is non-proprietary. We built this ground up using open source Python APIs. It's scalable because we're using XGBoost as our base model. And you can actually just put it on this thing called a pickle file and just deploy it into your systems and make the predictions on site. And it's adaptable. As Pat said, XGBoost, you can kind of understand how the features interact. So when we get more context about what these features are, you can take stuff out or put stuff in to make this model more robust. And with that, thank you. Any questions?
Okay, questions for, I think is it brother? Are you guys brothers? Is that correct?
Yeah, we're brothers. We've known each other for too long.
Yeah. Awesome. Questions? Do you have a question? He's interested. Anybody from the Shell team? Any questions for the team? Yeah, thank you. Thank you.
So in that fancy visualization dashboard you created within Tableau, so I see like you have several different features playing out, But we have hundreds of features in our data set. So how do you decide which features you want to put up there? Do you decide by their weight of importance or something else?
Well, right now it's a data-driven problem, so we just took the feature importance and what the model told us, but given better context when talking with the subject matter experts, we hope to find a better context and actually include the right features and make new features too. Yeah.
Any other questions from Team Hess? I'm sorry, my bad. Team Shell, that's a faux pas. Nope, all right. Big round of applause. Thank you so much.
Thank you, Bezier Brothers. And now I'd like to turn the mic over to Carolina Rio with Shell for some closing words.
Hello, everybody. It's been great to be here with you. Thank you all the teams that presented. It was really amazing to see what the hard work you put for this challenge. Thank you for the team from Shell who came here to be the judges of this presentation. Game Changer is a program for Shell to fund technologies in the early stage of development of some impactful technologies. So the program has a website, it's open throughout the year, so you can go visit shell.com/gamechanger, and you can see the criteria we use. And we are here to really map the community and understand better how can we work together, how can we fund good ideas, because we know how hard you work in this community, and we really wanted to get some leverage of that. So if you have a good idea, if you have an idea of a startup, go and talk to us. Thank you so much. Thank you, Top Coder, because you guys have been amazing. It was great to work with you, and we want to keep working. Thank you.